Assalamualaikum and salam sejahtera. In this video, I will be discussing some sample questions with regards to the topic that I have covered for the past 2 weeks. Okay, so for question 1, you have a cylindrical silicon specimen with a 5 millimeter diameter and 50 meter long that has a current of 0.1 amp passing through it in an axial direction. So the first part of the question is asking you to find the electrical conductivity, and the second part is for you to find the resistance over the entire 50 meter of this specimen. Okay, so we know that conductivity is reciprocal of the electrical resistivity. And to find resistivity, we need to find a resistance value first. So that is the first step here. Based on the info given in the question, we can calculate resistance using the Ohm's law. And we found that the resistance is 125 ohm. So next, we can use this resistance value to find the resistivity, which is just resistance times area over the length, and we found the resistivity to be 0.06459. And finally, based on this resistivity, we can find our conductivity, which is just the reciprocal of the resistivity. Okay, that is the first part of the question. The second part asks you to find the resistance of the entire 50 meter specimen. Remember that resistivity that we found in part A when we were calculating conductivity is a material property. So regardless of the length of this specimen, we can use this resistivity because it is a material property, right? It is independent of the size or length of this specimen. So we use that resistivity value to find our resistance, and we found the resistance to be 164.474 ohm. Okay, so that was question 1. Okay, so for question 2, you have an N-type semiconductor with an electron concentration of 3 times 10 to the 18. And if you are given the drift velocity of 100, in an electric field of 600 volt per meter, you are asked to calculate the conductivity of this material. Okay, the formula for conductivity of an N-type extrinsic semiconductor is given by this equation. Right here, it is not an exact value, that's why you have this type of wiggle equal sign. Because remember, you still have a contribution of hole, even though this is an N-type semiconductor. However, the concentration of the free electron is much more prominent in comparison to the hole. That's why the majority carrier is the free electron, and we have this equation for the conductivity of an N-type extrinsic semiconductor, whereby this N here is the concentration of the free electron, and you have the E is the charge, and you have this mu E is the electron mobility. So if you have a P-type extrinsic semiconductor, this N here is basically you just replace it with the concentration of the hole, and your mobility of electron becomes the mobility of the hole. Alright, so we are given the value of N, and also we know that this E is a constant. However, we are missing a value of this electron mobility. This electron mobility is basically just the drift voltage over the electric potential. And we found the mobility to be 0.1667 meters squared per voltage second. And to find the conductivity, we just apply this equation right here now that we have all the value of N, E, and the mobility. So the conductivity is 0.08. Okay, now for question 3. What are the 2 types of impurities that can be added to the semiconductor? Okay, remember that the intrinsic is a pure silicon. So when you add an impurities, you're basically saying that you are dealing with an extrinsic semiconductor. Okay, so for extrinsic semiconductor, the two type of impurities that can be added. The first one is the donor, which is an atom with 5 valence electrons, and because of this 5 valence electron, you have an excess of free electron, which makes this conductor that has been doped with this donor atom an n-type semiconductor. And second type of impurity is the acceptor, which is the atom with 3 valence electron. Because of this 3 valence electron, you have an excess of holes, which makes this semiconductor a p-type semiconductor. Okay, I believe this is the last question for electrical properties. This question asks you to explain why there is no hole generated by the electron excitation involving a donor impurity atom. So just now we said that donor impurity atom is an n-type semiconductor because we have an excess of free electron. Okay, the answer is that no hole is generated by an electron excitation involving a donor impurity because the electron is excited from the impurity level within the band gap into the conduction band. So basically, if you have a donor impurity atom, it created a donor state, just as shown in this figure right here, and the electron excitation happened from this donor state. Right, therefore, you don't have any hole within the valence band. Okay.